just to start off, what is the cloud as we know it? When we talk about the cloud, we've got this idea of this abstract platform where we connect our internet-powered devices, for all sorts of services, be it, music, IoT, right? And with the advancements of semiconductor technology, you've got all these embedded devices that can interact over the internet, right? And it's basically just blowing up into something huge, which the world is now relying on, right? More and more services are being added onto the cloud, right? And that is from a user perspective. And then from a developer perspective, right, we understand the cloud to be this place where, this platform where we develop our apps, deploy them, right? And offer them as a service, right? So you've got this, consumer side and this engineer's perspective as well, right? And the main cloud providers that we know, the big names basically are AWS, Oracle Cloud, Microsoft Azure, Google Cloud Platform, right? And I'm sure there's much more, but these are the main ones which probably are just dominating the market, right? And as mentioned, today we're going to focus on AWS and the whole Erlang ecosystem as well, right? So just drilling into AWS, right, and just looking at how it's distributed globally, right? So it comprises of multiple regions across the globe, right? And within each region, right, you've got multiple data centers, right? And those data centers are usually redundant, right, for high availability, and that is what is called an availability zone, right? So within each region, you've got multiple data centers. Each DC is basically an availability zone, and the redundancy is to ensure that in case one data center goes down, you still have availability on the other side, right? And there's also optimization for things like data acquisition, right? So you've got things called edge locations, right? So basically, what AWS does, it basically caches some data based on the region that you're in, right? To allow, better usage of the network and, low latency when you're using your apps online, right? So that's just a rough, pictorial view of how regions are distributed around the globe, and they're still growing, by the way, right? So just as an intro as well. So, what are data center networks? So just taking a bit of a more technical look at, when we talk about data center networks, what exactly are we referring to, right? Before we get into the whole, Erlang and Elixir side of things, right? So if you look at a data center, right, this is a picture taken from, one of Google's data centers, right? You've got all these racks, right, which are all interconnected into a very huge network, right? So remember, this is within a single region, right, and multiple data centers, and this is just a single data center, right? And you've got all these cooling facilities as well, which basically just to moderate all the energy emissions that are being emitted by all these servers, right? Because it gets really hot in there, and right, even the cooling and ensuring just the environment around is well maintained is a big thing, right? So that's basically just inside a data center. And then again, if we look at the actual network, right, structure or network topology, right? So what you usually have is all those racks, right, in the data center. They connect to what is known as TORs, right? So top of the rack switches, right? And those switches then connect to the to the larger scope of the internet, right? So and the data center network. So basically, that is basically just a high-level topological view of how these data centers are structured, right? And some of the performance, metrics or performance, attributes which need to be taken care of. They are the routing, right? The path selection of the data, right? Is this being traversed from one server to another, right? Because there's a lot of traffic that is being interacted across the servers, right? There's also congestion control, which needs to be taken care of, right? And the entire performance of the data center, when you look at things like throughput and latency, right? So these are some of the things which data center engineers have to be concerned about and have to always make sure that things are working efficiently, right? And yeah, and then drilling down again into the data center network, right? So this is basically, this is an illustration which was given by Cisco, right, on the typical architecture of data centers, right? So this is just the general purpose architecture of DCs, right? And what you have there, you'll notice you've got things called edge routers, right? And you've got aggregation routers, which then all connect to the core, which then connects to the wider scale of the internet, right? And at the bottom there, you've got all the servers which are hosting all these services and applications which we use on the cloud, right? And usually data centers are classified into two types, right? So you've got what are known as switch-centric data centers, right, and server-centric data centers, right? So if you look at the whole network architecture of data centers, right, that's the main classification that is used there, right? And with switch-centric data center networks, right, these are data centers where all the routing is handled by the switches, right, and the routers, right? So that is the main distinction there. And then with server-centric data centers, you've got the servers as well, not only hosting the apps, but also participating in the routing logic as well, right? So so basically that's the main idea there. But yeah, obviously the predominant architectures that are used are mostly switch-centric data centers, right? Okay, and then going a bit further, like I said, this is just a general purpose illustration, looking at some types of data center network topologies, right? For instance, this is known as the fat tree architecture, right? So why? Because it depicts the fat tree network topology, right? So if you notice at the bottom there, you've got the aggregation routers and the edge routers, right, co-located with and grouped with the endpoint servers, right, in groups which are known as pods, right? So you've got these pods, which are basically just a grouping of routers and aggregation routers and edge routers, right? And and all of this is basically built to optimize performance, right? And then one important thing about this architecture is that all the links are basically the same, right? So they use the same link sizes. So for instance, if one of those links is 10 gigabits per second, right, then in a fat tree network, right, all links are going to use that that link size, right? So this is a fat tree architecture, and again, so this is classified under the switch-centric architecture because all the switches are doing all the routing, right? And and then you've got the servers basically just hosting all the applications and doing all the data management, right? Okay, and then another example, right, is the VL2 network architecture, right? So this is quite similar to the fat tree, right? But the servers and the aggregation and core routers are not grouped into pods, right? So the whole pods, so basically that grouping is also used in the routing scheme. So if you look at the routing tables, right, that's where it actually matters and where it facilitates the routing. But in VL2, you don't have pods, right? You've got these endpoint servers that are interacting with the core and the edge aggregation routers, right? And the main difference with the fat tree architecture here is that the links can use different bandwidth sizes, right? So you can have some links on 1 gigabit per second lines and the other links using maybe 10 gigabits per second lines, right? And all of this is just to optimize how data is, traversed across each data center, right? And again, this is an example of a switch-centric data center network topology, right? And and one more example, right? So this is called the B-cube level 2 architecture, right? So so with this one, the main difference here is, you've got the endpoint servers, which are working with the core and the aggregation routers the edge routers to do the switching of data as well, right? So not only are the servers hosting the applications, right, but they're also involved in the routing. So this is basically a server-centric data center network topology, right? So basically this is what you have. So if you if you look into data center networks, look at what AWS is running, right? If you go into their data center, you'll find some architectures which are similar to this, right? And and of course, we want to focus our attention on, running Erlang and Elixir applications and making the most of, what's already provided by these network, by these cloud providers, right? Yeah, so basically be looking at AWS. And if you look at AWS, right, AWS EC2 instances, basically the servers, basically, they use a factory like data center network architecture, right? So right at the bottom there, right, that is where we'll be running our Erlang and Elixir applications, right? That's where all the services are hosted as well, right? And yeah, basically, just to have that in mind when we build our systems as well, right? So yeah, that's the idea. So this is just to give you an intro on this, but yeah, if you want to look more into this, there's a lot of literature on this and white papers on this. Yep, you can just ping me and we can discuss this. Okay, so now giving an example of an application, right, an Erlang and Elixir application, right? So taking an existing application, RabbitMQ, I'm a big fan of RabbitMQ. So if you take RabbitMQ, for instance, right, if you break it up into its building blocks, right, and we say, let's imagine that we wanted to, strip out some of the, building blocks of RabbitMQ, right, and re-implement this on AWS, for instance, right, and reuse some of the services which are already provided by AWS, and only implement as minimal, Erlang code as possible, right? So only the core part, which is basically the MQP part, right? But the rest of the subsystems will basically just reuse the services which are already provided, right? And basically, the same ideas, you can take these and just apply them to some, any other Erlang or Elixir application, right? So first, we'll do some planning, right? So basically just map some of these subsystems to what AWS already provides, right? Some of the services which are already provided there, right? So starting with the core part, right? Well, the core part, we can't really map that directly to a specific service in AWS, right? But what we'd have to do, that's where you implement the code, right? Your business logic, right? And as I mentioned in RabbitMQ, this is the part which implements the whole MQP protocol, right? And yeah, you just have to write code, right? Implement your own business logic, and and the go-to service that you'd use there is your EC2 instances to host your Erlang or Elixir nodes, right? So do your implementation, bundle it up in an OTP application, right? Produce a release, right? And deploy on an EC2 instance, right? Very straightforward. And I'm sure most people are already doing this, right? And yeah, just looking at some EC2 instances, right? As part of that initial phase when you're just planning out things, right? So EC2 instances, right, use a naming convention where you've got the family name, the generation, tag, which basically represents, how the generation of that family tree, that family type, right? And then the size of the EC2 instance, right? And then within, within the family types, you've got various types again, which you can use, and all of these are optimized for different workloads, right? Memory, various aspects that you'd want to specify your hardware on, right? So that's just on EC2 instances, right? And again, EC2 instances, right, by default, they don't come with any storage, right? You need to use the Amazon EBS block storage, right? So that's where you decide whether you're going to use, a hard disk drive or solid state drive, right? And another important metric there when you're selecting the type of disk that you're going to use is the EBS bandwidth metric, right? So basically this represents the bandwidth that you have between your EBS and your EC2 instance, right, for data interaction, right? So if you're going to have quite a lot of reads and writes, then you'd want to probably pick something with the high bandwidth metric for the EBS storage, right? So an example straight from the AWS website, right? You've got this table, right? For example, for the M family, you can see there's the virtual CPUs that you can look at, the memory, right? The EBS bandwidth, as I mentioned, right? in megabits per second, and the network bandwidth as well, right? So remember, going back to those network topologies that I illustrated, right? So you can have multiple EC2 virtual machines, right, that are running across different servers, all within the same data center, right? So depending on how you want your system to perform, right, then that network bandwidth metric becomes very important, right? Because even within the same data center, you still have a lot of routing that is being done by those edge and aggregation routers to traverse data across multiple servers, right? So these are some of the things that you'd have to look out for, right? And then from the Erlang VM perspective, right? I would say at this point, right? For example, if you're going to use a virtual machine with multiple, quite a lot of virtual CPUs, right? You can start planning out things like your emulator flags, right? Which you're going to use to start up your nodes, right? So things like scheduler bindings, right? How do you want, basically your processes to be spread across those virtual CPUs? And again, depending on your memory allocation, if you want to optimize or change the default memory allocator, which the Erlang virtual machine provides you with, right? At this point, right, along with planning for your hardware, right? This is where I'd say you start looking at some of these aspects as well, right? And a lot more, emulator flags. For instance, if you're going to be clustering and implementing high availability, even specifying like the default distribution buffer sizes at start will be a good point. Okay, and then and also as part of the EC2 instances, right, that you specify, right? So each AMI comes with a specific operating system, right? So if you know that your application is going to be handling quite a lot of concurrent connections, right? If you're going to need something to handle high throughput, right? So you can start tweaking even the OS settings as well, right? So things like TCP buffer settings, right? Increasing your file limits, right? If you're going to handle thousands or millions of connections, right? So these are some of the things that you do as part of initial planning for your EC2 instances to host your Erlang virtual machines, right? So if it's, for instance, let's say we basically select the M5 4 by large instance, right? So that will basically mark the completion of just that initial planning, right? And then alternatively as well, right? Amazon does provide a Kubernetes service, right? So if you don't want to go the EC2 instance route, right? You can use the AWS EKS service, right? So these are managed Kubernetes clusters, right? Which you can basically just deploy your release, right? And then Amazon will basically run that on Kubernetes, right? And basically handle all the scaling up and scaling down, depending on different traffic loads, right? And additionally, you've got an ECR service on AWS, right? So that's the container registry, right? So you can actually use the Amazon container registry for managing some of your images as well, right? So you don't have to go to Docker Hub for things like that, right? AWS already provides you with this, right? So that is just on the core part, right? And basically deploying that on a specific, specific hardware, right? And then if we continue with our, rebuilding of RabbitMQ or something like that, right? Just taking different blocks. If you take the database layer, right, or the data storage layer, right? So for instance, RabbitMQ uses Mnesia, right, as this primary database. It also uses, some persistent or disk-based storage for some of the queue implementations that it uses, right? So just looking at the database layer, right? If we're to switch this to AWS and reuse what the services already provided there. So AWS provides you with the RDS service, right? And DynamoDB. I'm sure most of you have already used this. So with RDS, you've got, for your relational data, PostgreSQL and MySQL services that are provided there. And with Dynamo, right, you've got a NoSQL-like database, right? So these are things that you can use off the shelf, right? So I guess for something like Mnesia, you could map some of the data to, yeah, some of it make it relational, some of it to, NoSQL to DynamoDB, right? And then additionally, you've got the Lambda service, right? So you can trigger some, code to execute dynamically based on, for instance, if certain objects are written to DynamoDB, right, and you want to trigger another action, right, you can make use of the Lambda functions, which AWS allows us to implement. And then also as part of the data storage, right, you've got S3, right? So if you've got things like images, large objects, videos, documents, right, you can just write those to S3 buckets, right? And do some streaming of the data there, right? And again, you can implement specific Lambda functions to trigger certain actions, right? Based on what is written to some buckets, for instance, right? So you've got all these options for data storage, right? Yeah, then continuing, right? Then another important layer in RabbitMQ, for instance, is the caching layer, right? And I'm sure in most systems that that you guys write, you use quite a lot of caching as well, right? So ETS is the primary caching system that RabbitMQ uses, right? Although I think, running that obviously on the Erlang node is actually more optimized than, externalizing that to an external service. But if we did want to do that, right, then on AWS, right, we can use the Elastic Cache service, right? So this provides us with the Redis and Memcached, right? Basically you can interact with Redis, so whichever system that you decide to use for the cache, using some open source APIs which have been implemented for that. I think obviously keeping that within the core node and using ETS is actually more optimized, because you don't need to route data across those servers, which we illustrated in that fact tree data center topology, right? Okay, and then then another part is the logging and monitoring, right? So if you wanted to extract that, right, and externalize it to a service that is already provided on AWS, for instance, right? AWS provides us with CloudWatch, right? So with CloudWatch, right, we can, do logging, right, monitoring of, all sorts of things, all services that you're using, right? And you can specify things like custom alarms, right? So you can create alarms, right, and do all sorts of, data filtering of logs, for instance, as well, right? And one important thing, right, looking at the logger application in Erlang and Elixir, right, you can actually implement a custom backend, right, for logger, and basically using that, you can then forward all your custom metrics straight to CloudWatch, right? So these are things that you can consider doing, right? If the default metrics provided aren't enough, you can implement your custom logger backend and forward all your logs to CloudWatch, right? Okay, and then proceeding to security, right? So for instance, in RabbitMQ, right, for you to carry out any AMQP operation, right, each user has to be authenticated, right? So security is quite a big part, and also on the on the AMQP connections, right, encrypting those with TLS is quite an important part as well, right? It's very, very common to do that. So how do you exploit AWS for security, right? So AWS provides us with a couple of things, right, that are specific to security, right? So you've got the IAM, right, and you've got the ACM and the KMS and the WAF, right? So basically, the IAM basically is for identity management across your services, right? So which user can access which service, right? And you can apply this to literally every subsystem or every service that you're interacting with, right? And then for certificate management, right, the ACM service, right, will allow us to use things like TLS, right, even on the load balancing side, right, or on the EC2 side, if we're if we're encrypting all incoming connections over TLS, right? So we can use the ACM manager to manage all certificates that we need to have on there, right? And then you've also got the KMS service, right, which allows us to encrypt all data, which is being, for instance, stored in S3 storage, right, or written in specific queues, right? So you can use the KMS service for that encryption, right? That's the key management service, and then you can use the WAF service as well, right, for application firewalls, right, web application firewalls. So to prevent things like cross-site scripting, right, and all such attacks, right? So these are things that you can use, which AWS already provides you with, right? Okay. And then the queuing subsystem, right? So if we take queuing and buffering of data, for instance, I mean, RabbitMQ, the purpose of RabbitMQ is to provide you with queues, right? And the queuing subsystem is quite a big and quite complex part of RabbitMQ, right? So, but if we decided, hey, want to extract this, right, and reuse the services which Amazon already provides us with, right, be it for RabbitMQ or any Erlang or Elixir application, right? So yeah, well, how would you go about that? So basically what AWS provides us with is this Amazon SQS service, right? The simple queuing service, right? You can use this, right, to do, basic FIFO queuing logic, right? Although it's not as complex or as you don't have as much flexibility as you'd get with, for instance, queues that are used in RabbitMQ. But for the basic queuing use cases and retries in case of messages not being delivered properly, right? You can use something like SQS, right? And then as well as EBS, right? The disk storage, right? So if we decided, hey, we don't want to use SQS, but want to implement our own disk-based queues, right? And also manipulate the memory storage for, transient data, right? So we can still make use of the EBS, the Elastic Block Storage subsystem, which I mentioned earlier, right? So yeah, these are some options that you can take up for queuing, right? And then lastly, there's a plugin subsystem in RabbitMQ. Basically, what plugins are, right? I mean, from an external perspective, from any user, a plugin is this components that you can start and stop to extend the functionality of RabbitMQ, for instance. But internally, what plugins are? They're actually OTP applications, right? So whenever you start a plugin, you're actually starting an Erlang application, right, in isolation, and that basically interacts with other parts of RabbitMQ internally, right? So yeah, for instance, but obviously, I mean, there's tons of plugins out there, but yeah, and some of them don't really map to a specific service that we can use in AWS or any cloud provider, for instance, right? So, but just taking one example, right, the notifications. Just one example, notifications plugin for sending out SMTP messages, right? Sending out emails, right? We can basically map that to the AWS SNS service or the SES service, right? So SNS allows us to configure notifications, right, based on a certain action, right? So it can be email, right, SMS, or there's all sorts of notifications that you can specify there, right? So some of the use case you can directly map to some services which AWS already provides you with, right? And there is an Amazon SES service, right? Simple email service, right? So you can actually use that as well, right? Yeah. So after all that planning and mapping out of your different subsystems and what are you going to use in AWS, right? I'm going to write minimal code just for the business logic part, right? And then the next thing basically is looking at that, going back to that core part of your system, right? And remember that core part has to interact with all these other subsystems, right? So as part of your Erlang or Elixir code, right, you need to pull the right dependencies and the right libraries for you to interact with all these services that you've extracted and are going to be using on AWS. So looking at some of the libraries that are already there, right. So for Erlang, right, there's a very, very good library with the AWS APIs, right? So it's called Cloud. You can check it out, right? It provides APIs to interact with, all sorts of AWS services, right? So, implementing your core in Erlang and then, specifying Cloud in your Reba config and basically just doing all those API calls. You can basically implement the full scope of your application logic there, right? And then, so that's mainly for the AWS services, right? And for interacting with something like, RDS, right? If you're using PostgreSQL, you can use this PGSQL library, right? Also very solid, right? So, so those are some dependencies that you could use, right? And obviously there's a lot more. Remember, we also mentioned things like caching, right? So, you can also implement your own custom, caching APIs to memcached or Redis or use what's already there, right? And on the Elixir side, there's also this EX AWS library, which is quite popular, and I'm sure quite a lot of you have used it. But this is very quite solid. I mean, you've got the EX AWS main library, right? And then it comes with all these service modules that you also have to include, right? For instance, the EX AWS Dynamo DB library, right? So that's a service module that you use with the AWS dependency, right? So these are some of the dependency apps that you could use for interacting with AWS services, right? And of course, for interacting with the database, you can just use Ecto for that, right? It works really well with RDS services, right? Okay, so that's mainly on the core part and some of the subsystems, right? And then when we start looking at things like distribution, right? Let's say you want to now scale out your application, right? But at the same time, still using all these services that are provided by AWS, right? So, so looking at the core part, right? So for instance, again, taking our example, RabbitMQ, right? It's very common to cluster RabbitMQ into multiple nodes, right? For high availability. If one node goes down, the other nodes take over service, right? And on top of that, fronting that with the load balancer, right? So this is a very, very, common approach with RabbitMQ. But if we're translating this into AWS, right? Taking the core part of our, application, right? And running those on EC2 instances, right? So what it means, you basically, join those nodes together to form a cluster, right? And they'll be running on EC2 instances, right? Each with their own block storage, right? For persistency. And again, on top of this, then you'd look at, using things like, the Elastic load balancer, which AWS provides you with, right? So you can just use that service for load balancing, right? And then again, what AWS provides you with is this EC2 auto-scaling service, right? So basically with auto-scaling, you can specify, right, as part of your target groups, which are basically the EC2 instances that you're running, the max capacity and the minimum capacity that you want to have. And if a node goes down, AWS will basically automatically spin up a new instance for you. And that's how you can make use of some of the services which AWS gives you for auto scaling. Then additionally, if you're to use the EKS service, right, for Kubernetes, right, what you can do is, obviously with Kubernetes, all the auto scaling will be handled automatically, right? So if you're not using EC2 instances, right, you have your Kubernetes service running and specify your replicas, and basically that would handle all the auto scaling cases, right? But remember, this is on the on the platform side, right? well, this is not high availability on the Erlang distribution side, which we're going to look at just now, right? And then additionally, if you want to use things like DNS, right, domain names, right, so you can use the Route 53 service, right, to expose, for instance, your load balancer IPs, your APIs over a specific domain name, right? So the Route 53 service is, it's pretty good for doing DNS, right? And then additionally, you can use things like CDNs, right, content delivery networks, for optimized data acquisition, right? We did mention at the beginning that you've got all these across regions, you've got all these edge locations, right, which are optimized for instance, reading large files. For instance, a user in Australia downloading a data which is, for instance, hosted in US East, right? So with CDNs, right, all that data can be optimized and cached in the local data center in Australia, for instance, right? So you can use CDNs for that, right? So yeah, and then looking at it from the Erlang distribution side, right? Remember when we build a cluster as well, you've got Erlang distribution, which is also continuously sending tick messages across nodes, checking availability, right? If nodes go down, right, you've got all these up down notifications that are sent across the kernel app within the Erlang VM, right? So, and one thing to take note of here is that you can hit cases where you get partitions from the Erlang distribution side, right? But from the AWS perspective and auto-scaling features, right? It might not pick up that your nodes are not interacting, right? So these are some of the things that you need to look out for, and probably you need to build a bit of additional logic there, right? Because the health checks, which for instance the Elastic Load Balancer does, are only on the host VMs, or host machines perspective, right? Whereas the Erlang VM, right, does all its own health check calls, or basically these tick calls which it does, right? So basically that's something that you need to look out for, because you can get nodes going down, but auto scaling from AWS perspective not being triggered, or the other way around, right? So yeah, that's basically it there. And then after clustering, right, there's things like CI/CD, right, continuous integration and deployment, right? AWS also provides us a lot of services around that, right? You can look this up, right? You've got code commit, which works as a code repo, and you've got code build services to build and test your applications dynamically as you push code, right? And for deployment, right, you've got things like CloudFormation, right? So CloudFormation basically takes JSON and YAML specification of your infrastructure, and basically would handle all the deployment that you need to do, right? And you can schedule this in different in specific pipelines, right, using the code pipeline service, right? So yeah, that's on continuous integration and deployment. So you don't always have to use Git or things like Terraform, right? You can actually use services which AWS already provides, right? But again, all of this, just to round up, it does come at a cost, right? So yeah, that is that's the pinch of all of this. But yeah, you do have all the services available to implement your applications, right? And yeah, that's it. I've got some references there. You can look them up if you're gonna do some reading as well. And yeah, that's mainly it.